Have you ever gazed upon the night sky and wondered if the moon is getting closer to the Earth? A question that has intrigued humanity for centuries. To understand this, we must first come to grips with the basics of the moon's orbit and its distance from our planet. Consider the moon's orbit. Unlike a perfect circle, the moon's path around the Earth is slightly elliptical, meaning it's shaped more like a squashed circle or an ellipse. This unique path results in the distance between the moon and Earth varying throughout the lunar month. Now, let's talk about gravity, the invisible force that keeps the moon in orbit around the Earth. It's a delicate balance. The Earth's gravity pulls on the moon, keeping it close. Simultaneously, the moon's forward motion, or inertia, keeps it from falling directly into the Earth. This fascinating interplay between gravity and inertia is what creates the moon's elliptical orbit. Within this elliptical orbit, the moon's distance from Earth is not constant. There are two key points in its path we need to discuss: apogee and perigee. Apogee is the point in the moon's orbit where it is farthest from the Earth. Conversely, perigee is the point where the moon is closest to Earth. During apogee, the moon might seem smaller in our night sky, while at perigee it appears larger and brighter. So we've established that our moon is a celestial body of intrigue, its path dictated by forces beyond our control. Its elliptical orbit, influenced by gravity, brings it closer to us at certain times and farther away at others. It's a dance of cosmic proportions, one that has been happening for billions of years and will continue for billions more. So, does that mean the moon is indeed inching closer to us? Well, to answer that, we must delve deeper into understanding the moon's orbit, tidal locking, and the gravitational forces at play. And that's exactly what we're going to do in the following scenes. Stay with us as we unravel the mysteries of the moon's movements. To answer that, we first need to understand the moon's orbit. Diving right into it, the moon's orbit is quite fascinating. It's not a perfect circle, but an ellipse slightly stretched out, and it takes about 27.3 days for the moon to orbit the Earth. This is known as a sidereal month. But if we're talking about phases, from full moon to full moon, that's a bit longer at about 29.5 days. This is called a synodic month. Now here's a fun fact. The moon rotates at the same rate that it orbits the Earth. This is known as synchronous rotation, and it's the reason why we only ever see one side of the moon from Earth. The side we never see, often called the dark side, isn't always in shadow, it's just hidden from our view. Next, let's talk about the tilt. The moon's orbit is inclined at an angle of about 5.1 degrees relative to the Earth's orbit around the Sun. This inclination means that the moon isn't always in the same plane as the Earth. Sometimes it's above the Earth's equator, sometimes below. This is why we don't have a lunar eclipse every time there's a full moon. The last piece of the puzzle is the precession of the moon's orbit. Picture a spinning top. As it spins, it also wobbles around. That's what the moon's orbit does over the course of about 18.6 years. This wobble, or precession, changes the times and places where the moon rises and sets, which can have a dramatic effect on tides here on Earth. So there you have it. The specifics of the moon's orbit, a complex dance of rotation, tilt, and precession. It's this intricate ballet that shapes our nights, influences our tides, and yes, even affects the distance between the moon and the Earth. Now that we understand the moon's orbit, let's look at what influences it. Gravitational forces play a significant role in the moon's movements. Now, let's delve into the intriguing concept of tidal locking and the gravitational dance between the Earth and the moon. Tidal locking, or gravitational locking, is a fascinating phenomenon that occurs in most celestial bodies' relationships. It's like a cosmic tango, where one partner becomes so engrossed in the other's moves that it ends up always showing the same face to its partner. The moon is tidally locked with the Earth, meaning that we always see the same side of the moon. It's not that the moon doesn't rotate, it does. However, it takes the same amount of time to orbit the Earth as it does to rotate on its axis, resulting in the same lunar face always being on display. But what causes this tidal locking? Enter the gravitational forces. Earth's gravity pulls on the moon, and due to the moon's uneven mass distribution, it creates a torque that slows down the moon's rotation. Over billions of years, this has led to the moon's current tidally locked state. However, it's not just a one-way street. The moon's gravity also affects the Earth, most noticeably in the form of tides. The moon's gravitational pull causes the Earth's waters to bulge out towards and away from the moon, resulting in high and low tides. It's a delicate balance, a cosmic ballet, if you will. The Earth and the moon constantly pull on each other, maintaining their respective positions and orbits. However, even the slightest change in these forces can lead to significant changes over time. These gravitational interactions also play a part in the moon's distance from the Earth. As the Earth's gravitational pull slows the moon's rotation, the moon moves slightly further away from the Earth. This is a gradual process, happening at a rate of about 1.5 inches per year. So, with these forces at play, what happens to the moon's distance from the Earth? Well, that's an intriguing question, and the answer may surprise you. Stay tuned as we delve deeper into this cosmic mystery in the next scene. Is the moon getting closer, or is it moving away? This is the enigma we've been waiting to unravel. To answer this question, we delve into the world of celestial mechanics and the fascinating dance between the Earth and its solitary satellite. Believe it or not, our moon is on a slow but steady journey away from us. Yes, you heard right. The moon is receding from Earth at an average rate of 1.5 inches per year, a phenomenon largely due to tidal friction. Let's break this down a bit. Tidal friction is a result of the gravitational interactions between the Earth and Moon, causing Earth's rotational energy to be slowly transferred to the Moon's orbital energy. This process propels the Moon into a higher, slower orbit around our planet. But what does this mean for us and our lunar companion in the long run? Well, the effects are rather intriguing. As the Moon recedes, Earth's rotation gradually slows down. This means that billions of years from now, a day on Earth could last as long as a month in our current reckoning. On the Moon's side of things, its orbit will continue to enlarge until it reaches a stable point. However, this doesn't mean that the Moon will eventually escape Earth's gravitational pull and drift off into space. The Sun's gravity also plays a role here, ensuring that our Moon remains Earth's faithful companion. This slow lunar recession also has implications for solar and lunar eclipses. As the Moon moves further away, its apparent size in our sky decreases, making total solar eclipses a rare spectacle in the distant future. So, contrary to what we might think, the Moon is not getting closer, but is slowly drifting away. While this might seem a little disheartening, fear not. This process is so slow that it won't significantly impact any of us in our lifetimes. So for now, we can continue to enjoy our Moon's comforting glow, secure in the knowledge that it's not going anywhere anytime soon. Let's summarize what we've uncovered in our lunar exploration. We've embarked on quite a journey, haven't we? From understanding the mysterious movements of the Moon to delving deep into its orbit, we've unraveled some of the most fascinating aspects of our celestial companion. We began by discussing the Moon's orbit, a complex dance of celestial bodies. Remember, the Moon doesn't travel in a perfect circle around the Earth. Instead, it follows an elliptical path, which means its distance from us changes throughout its orbit. At times it's closer, creating those breathtaking supermoon events, and at other times it's further away, leading to the phenomenon we call a micromoon. We also explored the concept of tidal locking, a term that might have seemed alien before we started our journey. Tidal locking is the reason we always see the same side of the Moon. It's a gravitational harmony between the Earth and the Moon, where the Moon takes the same time to rotate on its axis as it does to orbit the Earth. But the most intriguing revelation was perhaps the fact that the Moon is not approaching us, but rather, it's slowly receding. Yes, you heard it right. The Moon is gradually moving away from us at an average rate of about 1.5 inches per year. This happens due to the transfer of Earth's rotational momentum to the Moon's orbital momentum as a result of tidal friction. This slow drift may not seem like much, but over millions of years, it has caused the Moon to recede from the Earth by a considerable distance. This phenomenon has implications on Earth's rotation, the length of our day, and even the illumination of our night sky. So next time you gaze at the Moon, remember, It's not falling towards us, but is slowly drifting away, making our nights a little less bright over millions of years.